We're going to talk about the family of quadratic functions, and we're going to do the basics. We're going to review the zeros of a quadratic function that you've known as roots all these years, but they're also known as zeros because we always put y equals 0. We're going to talk about the quadratic formula to find roots or zeros. We're going to talk about all the different formulas for quadratic functions. There's 3 different forms that we use. We're going to do a lot with applications, and we're going to do something we call completing the square. Let's look at a graph of a parabola, which is a quadratic function. Here we have a y equals, it's an equation. We have ax squared, and notice we have this 2 is squared. When you square the x, it bends the line so it turns into a parabola. Plus bx plus c. This is called the standard form of a quadratic. This is what a quadratic looks like, and I have labeled everything here. This line in the middle, which is always an x equals line, because it's straight up and down, it's vertical, is called the axis of symmetry. If you were to actually fold this parabola right in half, it'd be perfect. That's why it's symmetrical. It's called the axis of symmetry. Down here is the minimum point. We've also known this called as the turning point. They're both the same. We also can call it a vertex because it's the vertex of the parabola. It's right here where it turns and goes the other way. And it's always on the axis of symmetry. This parabola opens upwards. This parabola opens downwards, but it has the same type of features. You have your axis of symmetry that goes down, which is an x equals lines like I showed you. But this one has a maximum point or maximum vertex, if you will. Now, if a is positive, and this is the term that's in front of the x squared, the parabola will open upward and have a minimum point. I like to say this is a happy face parabola, and happy face parabolas have minimum problems or a minimum point. Conversely, if a is negative, the parabola will open downward and have a maximum point. I say a sad face parabola has maximum problems. Alright, we're going to get a little bit more into the graphs of these. So if you were to graph this, and I graph this one right here, it's the parabola x squared minus 4x. Here's my x values, here's my y values. I want you to notice something about the symmetry of this graph. First of all, look at my y's. My y's go from 5 to 5, and then see how it repeats, and then this part right here, this point right here, 2, negative 4, is your turning point or your vertex. So this is the vertex or the turning point. All the rest of these points are on the graph. The other ones I wanted to show you is this point right here, 0, 0, where my y's are 0. These are your zeros or your roots, because this is where y equals 0. And every time we look for your roots, we always put y equal to 0 and we look at it. So if you'll notice, this is also where it crosses the x-axis. So that's some of the basics I wanted to show you with that. Again, the a is positive, so it's opening upwards, and you can look at it in that respect. Now let's talk about the roots and zeros. The points where the graph crosses the x-axis are called roots or zeros. In this case, I showed you have 0, 0, and 4, 0, and the axis of symmetry is a vertical line, so let's draw it. So here's a point 2, negative 4. The axis of symmetry is right here, and it's an x equals line, and see how the 2 value right here of my point is 2? So this line is called x equals 2, and the x of my point is also 2, but this is the actual equation of that line. Alright? The other way we can find roots or zeros is, we have this in standard form. Notice our y is equal to 0. Is we can use the quadratic formula. Now I've already showed you a video on the quadratic formula, and we've already practiced doing the roots, but I put it here for just for to have it all together for your notes, and also for some refresher. The A, B's, and C's in this formula are all based on the quadratic formula and the equation. Here's the axis of symmetry. The axis of symmetry is x equals negative b over 2a. That's how you find the axis of symmetry, and so you're using this, you're negating it over 2 times the axis of symmetry. If you were to look at the formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, if you were to circle just the front of this before you get to the plus minus, you would have your axis of symmetry. So it's not necessary that you memorize this because it's part of your formula. Again, I have this here. If you were to look at this, you can tell if the roots are rational or irrational roots by looking at your discriminant, which is what's underneath the radical sign. This is called your discriminant. So you can look at it to tell what's going on with your roots. So for example, if it's a perfect square, I know I'm going to have rational roots or rational zeros. If it's a 0 underneath the radical, then I know I have 2 roots exactly the same, so your parabola just touches the x-axis or is parallel to the x-axis if this is 0 inside here. So here's the first one, the second one if it's 0. The third one is if it's not a perfect square, like this radical 37. If it's not perfect, then I know I'm going to have irrational roots. And the other one that's kind of fun, I'll put this over here, is if you get a negative underneath the radical, that means it doesn't even touch the x-axis and they're imaginary roots. They're not real. The way to find this, you can solve quadratic equations by factoring, and we've done this before. You can use your common monomial factors or your eyeball, if you will, to find the GCF. Do your binomial factors and factor completely. You can do that by factoring, but not all equations are factorable. So a lot of times you can use the quadratic formula. So let's practice a couple. I'm going to do it both ways. But this one right here, in order for you to find roots or zeros, you have to make y be 0 or f of x be 0. So we're going to rewrite it like this. And so when I write it like this, let's try this by factoring. So this one's an easy one to factor. I have x. Make your big T. Make sure you put each of these pieces equal to 0. And this equals, okay, the points where it crosses the graph is the point 3, 0. See how the y is 0 and negative 2, 0. So I know this crosses the graph, and since a is positive, I know this opens upwards. Now if we want to use the quadratic formula, I hope you're kind of singing this in your head like I am. You're going to stack and rack A equals, B equals, C equals, and D equals, which is your discriminant. So the A is 1, the B is negative 1, and the C is negative 6. This is B squared minus 4AC, so that's 1, because that's B squared minus 4 times A times C, which is 25. So I got X equals negative B, so it's 1, plus or minus radical 25, all over 2 times 1, or 2a. This will split up to 1 plus 5 over 2, 1 minus 5 over 2, because we have 2 roots, got to do the plus minus, so we'll do the plus and the minus. So this is 6 over 2, or 3, and this is negative 4 over 2 or negative 2. So we get the same roots doing it either way. This practices again, and this is more a pre-calc way of doing this. Sometimes you can get equations just like this, and I don't want you to get nervous or say, oh my goodness, I have a fraction in here, what am I going to do? Well, there's a couple ways to handle this. The first thing I did was I put it equal to 0. So I have x squared minus 8/3 x minus 1 equals 0. Well, when you put it equal to 0, and now that you're in pre-calc, sure, I could say a is 1, b is negative 8/3, and c is negative 1, or I can multiply everybody by 3. Because if you do that, you're not changing the equation, you're changing how it looks. So I actually end up with something like this: 3x squared minus 8x minus 3 equals 0. And you can use that to factor or do the quadratic formula. This one's an easy factorable one, so let's do this one. Now you can split the middle if you want. I have 3x and x, and I have a minus 3 here and a plus 1. So see if that works. Yes. Big T, 3x plus 1 equals 0. 3x equals negative 1. X equals negative 1/3. X minus 3 equals 0. X equals 3. So the 2 points would be 3, 0, and negative 1/3, 0. That's where it crosses the x-axis. You can also put this in the quadratic formula. Now, if you do this in the quadratic formula, you could use this a, this b, and this c, or you could use this a, this. It doesn't matter. You're going to end up with the same answer. Okay, that clears for the basis of quadratics. Now, let's look at the three kind of formulas you can have for quadratic functions. We've been looking at the standard form, where you have a, b, and c, and they're constants, and a can't be 0, or else that wouldn't be a quadratic. This everybody's most comfortable with because they've seen it the most. The vertex form is a new form, a different form. This is the way to write the quadratic, and you can look at this by looking at the vertex. So right here, by really looking at it, you can say, wow, right there is my vertex or my turning point. Has an axis of symmetry at x equals a, and of course it opens upwards if a is bigger than 0 or positive, and downwards if a is negative. And the third form is called the factored form or zeros form, where you can write it like this, and these two parentheses tell us what our roots or our zeros are. So what do these formulas tell us? The standard form, again, if a is positive, it opens upwards. If a is negative, it opens downwards. So that tells us that. Here also, when x is 0, if I put a 0 here and a here, I'd have y equals a c. So that means our y-intercept, or where it crosses the y-axis, is whatever this number is. Because if x was 0, that would be our y-intercept. So that's what the standard formula tells us right off the bat when we look at it. The vertex form, like I just said, tells you the vertex, but before that it tells you a. If a is positive, you're going to open upwards. If a is negative, it's going to open downwards. So you can tell that by looking at here. Now here, HK is your turning point or your vertex of your graph. So this tells you a little bit different. And the only thing you have to be careful of is you've got to make sure this is opposite. So be careful. If you see a negative number there, you know it's opposite when you put it in for your vertex because the negative's there. Also, it tells you the axis of symmetry is x equals h. Whatever this number is there, that's my axis of symmetry. Okay. And the last one is the factored form, and like I showed you before, these are your roots or your zeros. And again, a does the same thing as it's done above. A is positive, it opens upwards, and a is negative, it opens downwards. So these three forms are all the same thing. They could be the same parabola, but by putting them in these forms, you can find out different information. This one you can find the y-intercept. This one you can find the turning point of the vertex and the axis of symmetry. This one, by just looking at it, tells you the roots. That completes our introduction.